So this is the most difficult question on ENGAA 2022. Section 1. A steel cable has mass 64 kilograms and cross-section area 2 times 10 to the minus 4 meters squared. Young modulus of steel is 2 times 10 to the 11 Pascal. When the cable lies on horizontal ground, its length is 40 meters. That's 40 meters. What is its extension when it's suspended freely from one end and hangs vertically? Okay, so if we draw a scenario when it's hanging, let's say this is 40 meters, it will extend due to its own weight. So, for example, the mass at the top feels all the weight of the rope, so that little spring would extend the most, or that bit of the cable would extend the most. The part at the bottom would probably not extend at all because it feels no weight below it. So, we could do a really technical thing here that I will show you, but we don't need to use it for this question, given that you're meant to do it in under 90 seconds. But it is a good practice of calculus. So if we looked at a little section here at a depth z, and this was little thickness dz, we know from the Young modulus equation that E equals force times natural length over A times the extension. So this is just using F over A divided by delta L over L. So the extension from any little bit will be F times L over A E. Now, the natural length of the little section I've put is dz, so I'll put L as dz. So the little extension is dz. The mass below that section would be the total length of the wire minus z. So if L here was the total length of the wire, which is 40, dz here is the natural length of just that element of the wire. So I've chosen this to be the natural length of that section of the wire, and then L here represents the total length of the wire. So the mass, or the weight below it, would be mg times L minus z over L, the fraction of the rope that's below it. Then, of course, divide it by AE. So if we wanted to get the total extension, we'd need to sum, so large S, sum up all these extensions. So I'd need to integrate this term between Z is 0 at the top and Z is L at the bottom. So we'd be adding up each little bit of force times dz. Now, you could carry out this integration and you'd get an answer of mgl over 2 AE. But I want you to think about how we could have got this answer quite simply. Well, there are two interpretations for this question. One, we can consider all of the weight to act at the center. So at L over 2. All of the mass, or all of the weight, could be considered there, as it's the center of mass. So that interpretation would look at it like this. This would be all the weight mg on a light spring of length L over 2. So a light cable that has no mass, but all the mass concentrated at L over 2 over AE. So that's one way to see it. Or another interpretation is the fact that every bit of the rope is feeling a different force. So we could work out what is the average force. And because it varies linearly, the average force will be right in the middle. So that'll be mg over 2. So we could say, translating this, that we could consider a long rope length L, and all the average force that every bit experiences is mg over 2 at the bottom. So this interpretation is mg over 2 times the whole length L over AE. And these two interpretations are equivalent. So you could either look at it the center of mass way, or you could think of the average force in the rope and then consider that at the bottom or the whole rope has a average force through it of mg over 2. So let's get the extension using this formula. Again, we're comparing this to that FL over AE. So it's either we have the average force for F, or we consider the whole force acting at L over 2, which would be the kind of natural length of this light spring. So putting the numbers in, as mentioned earlier, we would have 64 times 10, so for G, times L, which is 40, over 2 times A, 2 times 10 to the minus 4, times E, which is 2 times 10 to the 11. Now, 10 to the 11 times 10 to the 4, we get 10 to the 7, and then we've got a 10 on the top, so we get a 10 to the 6 on the bottom. But we also have a 40, so the 10 from there gives us a 10 to the 5 on the bottom, but the 4 cancels out with these two, and then we get the 10 to the 5, as mentioned earlier. And then we just get 64 over 2 times 10 to the 5. So that is 32 over the 10 to the 5, so that's times 10 to the minus 5. Passing over a factor of 10, we get 3.2 times 10 to the minus 4 meters. So the answer is 3.2 times 10 to the minus 4, G. Again, they cleverly put here an answer of H because they knew a lot of people would just consider the whole weight acting at the bottom, when this is different to the cases you're used to at school, where a weight is just hanging from a very light string. So this is a good question in that it tests your understanding of how the tension works and the fact that each bit will be feeling a different tension. So on average, it will be half the weight. Or we could consider all the weight, as you would have learned from GCSE or earlier studies, all the weight to consider to act at the center of mass, center of gravity. So if you have any questions, let me know in the comments. But it's a very difficult question, especially to do in 90 seconds. But I feel like the calculus you could use here is a very neat way of doing it if it were to come up in an interview setting.